Good evening students. Today I am going to teach you the application of dimensional analysis. It has 3 to 4 varieties of applications. Let us check the first application. The first application is to check the correctness of an equation. Suppose one equation is given, a mathematical relation between all the physical quantities is given. To know whether that equation is correct or not, this dimensional formula is useful. This concept is based on a very fundamental and a very layman's idea that whenever we are adding physical quantities, the physical quantities having same dimension are added with each other. One example means mass is added with mass. Mass cannot be added with time. The simple thing. So let us take one example. Like suppose a quantity A is there. A is equal to B plus C into D. Like this. Here the left side quantity denotes your A. The dimension of A must be equals to the dimension of B. B is added with C into D. It means what? This quantity means C into D must have the same dimension as that of B and as that of A. So the dimension of A must be equal to dimension of B must be equal to dimension of C into D collectively. Clear? So first term, and let us take it to be second term. So it is your LHS. So the dimension of LHS must be equal to each and every term, dimension of each and every term on the RHS. Clear? Let us take two examples here. The first example is S is equal to UT plus half AT square. So that the principle what I have said, that is called principle, it's a fundamental principle got here S is equal to UT plus half AT square. S is your distance, U is the speed, T is time, and here A is your acceleration. Now you see LHS is your distance, so the dimension of distance is L1, and U into T, the dimension of U into T, U is your speed, so the dimension of speed is L1 T minus 1, into T is there, so it is T1, so if you multiply you are going to get L1. Now half AT square, dimension of half AT square. Half is a constant, it won't have any dimension. A is the acceleration, that's why I have written L1 T minus 2, and for T square it is T to the power 2. So now if you can solve, you are going to get L1. Clear? So you see all of you, dimension of S must be equal to dimension of U into T must be equal to the dimension of half AT square. Here it is L1, L1 means this equation is correct. It's a correct mathematical relation. Now comes to the second example. T is equal to 2 pi root over of L by G. Here T is the time period of a simple pendulum, oscillating simple pendulum. L is the length of the simple pendulum. G is the acceleration due to gravity. Now you see the dimension of LHS. It is the time, so dimension is T1. Right side dimension, 2 pi is the dimension is quantity. That's why the dimension of the RHS must be equal to L by G's dimension, root over of L by G's dimension. L is the length, so for that I have written L. G is acceleration produced by the gravity, that's why it is L1 T minus 2. Now root over of it. So here LL got cancelled. T to the power minus 2 it was there in the denominator. When it is come up to the numerator, it will be plus 2 square of, or means T squares root over, it will be T to the power 1. So you see the dimension of LHS and dimension of RHS must be same. Got? So this principle is called the principle of homogeneity. Means we can add similar, or we can add physical quantities having similar dimensions. Clear? Now basing on this concept, let us solve this question. The question is like this. A quantity P is given by your A minus V by B into T, where is the power, V is the speed, T is the time. A and B are two different quantities. The question asked here, find the dimension of A into B. So individually we need to find out dimension of A first, dimension of B, then we multiply both the dimensions to get this quantity's dimension. Clear? Now we can apply the principle of homogeneity in this case. See here, we can split that term. P is given by A by B into T, A by B into T minus V by B into T. Got? So there are three terms, LHS one term and RHS one and another term. Got? So the dimension of all the terms must be equal. So if you are knowing the dimension, it is well and fine. Otherwise you can calculate here. So first find out the dimension of power. Power is what? Work by time. Yes. So the dimension of work or energy, they must be having same dimension. So which is M1 L2 T minus 2 divided by T. So the dimension of power is given by M1 L2 and it is T minus 3. So it is the dimension of your power. Dimension of speed, you know the dimension of speed is L1 T minus 1. Got? Now we can, and the dimension of time as a fundamental quantity, its dimension is T. Now you can find. So here we can write the equation. The dimension of P must be equal to the dimension of A by B into T must be equal to the dimension of V by B into T. Got? So this is the required equation while solving for solving our question. Now if you compare dimension of power with this quantity, you will be going to get the dimension of B. So now you can compare dimension of P must be equal to dimension of V by B into T. Now I can reshuffle. The dimension of B must be equal to here the dimension of V divided by dimension of P into T. Now I can put the values over here. V is L1 T minus 1 by power. Power is M1 L2 T minus 3 into T to the power 1. Now I can solve for B and calculate. See here, it is M to the power minus 1 and here it is L to the power 1 and here it is divided by L to the power 2. So it will be L to the power minus 1. Now you see here, it is minus 3, it is 1, means minus 2, T to the power minus 2. When it is go up, then it will be T to the power plus 2 and here it is minus 1. So your answer will be T to the power simply 1. So the dimension of B is this much. Now let us find out the dimension of A. So we can find the dimension of A like this here. So if you equate these two equations, so it's clear. So the dimension of A must be the dimension of P multiplied with the dimension of B and T. Dimension of P is this much, which is M1 L2 T minus 3, and the dimension of B just now we got, which is M minus 1 L minus 1 T1, and here it is T again. Now I can simplify. Here you see M1 M minus 1 got cancelled, means M to the power 0. Here L to the power 2 and here it is L to the power minus 1. So it would be L to the power 1. Now here it is C, T to the power 1, T to the power 1 means T to the power 2 and L to the power minus 3 means, T to the power minus 3 means T to the power minus 1. So the dimension of A is L1 T to the power minus 1. Now your question is asked here, find the dimension of A into B. So now I can find A into B, multiply this dimension of here with that quantity. So you are going to get A is L1, A is L1 T minus 1 multiply dimension of B, which is M minus 1, L minus 1, T1. So your dimension, if you find the product, you are going to get it is M minus 1, it is L minus 1, L1. So L0, T minus 1, T1, that is T0, or simply it is M minus 1. So the dimension of A into B is M minus 1. You can easily find the dimension of A here also in a simple manner. See, in the numerator, this velocity is subtracted from your A. It means similar physical quantity can be added and subtracted. Means if it is velocity, A must be velocity. The dimension of both the quantity must be same. So you could have directly find the dimension of A to be your dimension of velocity L1 T minus 1, what we have already calculated. Got? So this is one application.